So Marnie is saving for a school netball trip, which is a part-time job. Practices every Friday, 14 more practices. She decides to coach $20 for the trip at each of the 14 practices. Plot the graph. So practice 1, she's going to give $20, another 20, all the way up for 14 practices, giving another 20. She's given it all up. Of course we won't join, because at this stage this is the number of practices, this is the amount. It's discrete data, whole number data. First practice 20, second practice 40, third practice 60. There's no need to join that up. And question part 2, if a line is drawn, give the equation of this line. So if we were to put a line through there, y equals mx plus c for a straight line, I can see that the y-intercept would be 0 if it was there. We won't put it in, so there's no y-intercept. Working out the gradient, rise over run, it's clearly going up in steps of 20. Y equals 20x. And we should of course use the lettering that they've suggested. So on the y-axis we have a t, 20 times, and instead of x we would have p for the number of practices. $20 for the number of practices, and you can just check. If p was 4 times 20 is $80. And that seems to work. Right, the total cost is $300, and if you look up at this graph, she's not actually going to make it to $300 if she does that. After a few practices, she realises that she needs to start paying the coach $30 a week so that she meets her $300 target. Plot the graph of the changed amount she needs to pay. So the best way to do this would be to go backwards. She wants $300, and I'm going to change colour. So she wants $300, and if she pays $30, obviously she'd need to pay $270 the practice before that, and $240 the practice before that. So she could pay her $20 up until the 11th practice, the 12th practice, but by the 13th practice she needs to have paid a $30 and another $30, and then she'll meet her target. So we've drawn the graph. Part 4 says for how many weeks does she need to pay the increased amount, and clearly you can see there are 2 weeks when she'll need to pay the extra amount. So back to the red pen, 2 weeks. The equation for the graph representing the increased payments. Once again, we're assuming there's a line. We've only really got 2 points on that line. We know that for practice number 13, it goes through the point 270 on the graph, and practice 14 goes through the point 300. So they're my 2 points on the line. Now we can do this by hand, or we can do it on the calculator. We want the equation of a straight line through these 2 points. So if we try it on the calculator, let's delete that column using the delete button. So if we put 2 points for a straight line is enough. It's not enough for a parabola, but it's enough for a straight line. 270, 300, graph 1, calc. And now we want a straight line, so we're choosing x. And there I can see y equals ax plus b. Using their lettering, we're using t for the total amount. Now a needs to take the value of 30. Along the x-axis, we're using the letter p. And then b is minus 120. So you could check that. You could substitute 13 in there on your calculator. 30 times 13 minus 120, just check you get 270. Of course, if you wanted to do this by hand, you would start by finding the gradient, rise over run. So the gradient would be The rise, which would be 300 minus 270 is 30. The run is 1. So the gradient is 30. Y equals 30x plus c. And then to work out the y-intercept, it's too hard to just read it off the graph or to see where that would go through, but we could substitute a point, either one of those points. If we take this one, it looks a bit easier. And we substitute the point 14,300. So 300 equals 30 times 14 plus c. C is going to equal 300 minus 30 times 14. 30 times 14 is 420. And that gives us the minus 120. So y equals 30x minus 120. And of course you'd need to go and use the lettering. On the calculator is fine. Sam found a puzzle in a book. Think of a number, add 2, multiply by 3. 3 times that is 21. Add on your original number. Yes. Add 6. Yes. Divide by 4. And now if you're going to take away your original number, you get down to 3. We'll carry on with this column just to see what's happening here. If we add 2 to that, multiply by 3, that's correct. Now we want to add on your number, so if we add on the 10, now if we add 6, divide by 4, take away the 10, and I do get back to 3. Complete the third column, right. So we've added 2. Now I need to times everything by 3. 3 times n is 3n, and 3 times 2 is 6. Right, now we want to add on our number, so add another n. 3n plus n is 4n. We want to add 6. So that'll be 6 plus 6 is 12. We want to divide by 4, and you've got to make sure you divide both, the whole thing by 4. So 4n divided by 4 would be n. 12 divided by 4 would be 3. Now when I subtract my original number of n, I'm going to be left with 3. So when it says explain in detail why the answer is always 3 no matter, you really need to work through this and just explain it in words. So we add 2, then multiply by 3, add on your own number, which takes you to 4n plus 6. Adding 6 onto that gives 4n plus 12. Dividing everything by 4 will give n plus 3. And then when you subtract n, the original number, you get left with 3. And that's how it works.